So thanks everyone for coming along. I appreciate it's pretty late in the day and we might be a little bit talked out, so I'll try to keep it as interesting as possible. We'll see how we get on. Okay, I'm going to start with a question. So how many of you at some point have had to answer a question around that forced you to forecast or predict sometime into the future? So something like, are we going to get all these features, whatever these features are, done by the end of the year? Okay, that's good. So you're probably in the right talk. That's a good start. Okay, so what I'm going to talk about are a few ways that you can try to answer that question and generate some data that helps you answer it without falling down into the trap of trying to break everything up front and estimating everything, and then you end up with a whole bunch of upfront planning. So if we start, we look at how a lot of Agile teams report progress. They use something like this. So a burn chart. Green is obviously work that's done. The blue bit is stuff that is still to be done. And you start with some estimate at the start of how much work you've got. And it might go up at some point when you find there's more work to do. And then inevitably at the end, you suddenly decide some of the stuff you wanted to do is less important and kind of drop it down, and we get to a release and everyone's happy. So this works really nicely if you know what this blue bit is, but what if you don't know what that blue bit is? How do you go about working out how much stuff's here at the start of your project? So to do that, I'm going to introduce you to evidence-based forecasting. So I'm sure you're asking, what is it? Evidence-based forecasting is a way of using your team's historical performance to help predict how much work things they haven't estimated are likely to be. So because it's using historical data, it gets more accurate the more work your team's done. So it starts off at the start of a piece of work. It's going to be not super accurate, but as you get more through your work, it should become more and more accurate. I find it works best with a hierarchical backlog, or backlog with multiple levels in it. I tend to use 2 or 3 levels just because I find that's quite a good way of thinking about my backlog. So I kind of start with epic level features, break them down into features and then move into stories. It starts to help me think about what are the big buckets of functionality I want to deliver, and then everyone can have an idea of, okay, this is what the scope of this piece of work is, this project. And then as it gets closer to actually getting some people to code it, we'll start breaking it into features and then start breaking it into stories from there. But this approach works with anything, so any number of levels. You have just one, or you can have 6 or 7. The logic is quite simple and it works for anything. So let's look at an example of how it does work. So I've got an example product backlog here. It's quite a small one. We've only got 7 stories. And some of them have been estimated. We've got 4 that have got some estimates against them, 3 that don't. And one of them at the top, we've done it, so we know that's a 2. So the question is, how do we go about working out what the dark grey boxes are? So to do that, we just use average story size. So I hope there's no mathematicians in the audience. I thought that might look a bit fancier, but hopefully I've got it right. So we basically look at our backlog. We say we've got 4 stories with estimates. The total number of points that the team's estimated is 18. So our average of that is 4.5. Round it up and make it 5. So then we can just say, without looking at anything else, our backlog, those stories that we haven't got any estimates for, are probably going to be about 5. Obviously, some of them are going to be bigger than that, some of them are going to be smaller, but on average, as a finger in the air, that's a good starting point. So now, say we had 18 points to start off with in our backlog, and now we're kind of using that average, we can say, well, we're probably about 33 points. So this now starts to give you a bit better understanding of how big that backlog is. Now I said that it works better if you've got levels in your backlog. So if we pull that in and have a look at how that looks. So all I've got now is I've got some features, I've got some epics. So we can see this top feature is made up of 2 stories. They've both got estimates, so we can just add these up, and we can say this feature is 5 points, and it's only got 1 feature in the epic, so that's 5 points as well. And then when we start talking about these features here, it gets a little bit less clear because there's some unknowns in here. So we can predict that this feature is 13 and this feature is 15, and then we can say this epic is 28-ish. So once we've got our kind of backlog structured like this, when we start looking at perhaps this second feature down, this epic down here, we might be looking at breaking it up, and we realise there's a new feature that we haven't thought about before. So what we want to do is get a quick idea of how big this feature is. How big is it likely to be? What impact does that have on my backlog? So to work that out, again, we'll use a similar approach to what we did with the stories. But this time, instead of using the average size of the features, what we're doing is looking at the average number of stories that a feature has. So we'll look at the backlog. We'll say we've got 3 features in our backlog. We've got 7 stories across those 3 features. We work out the average, and the average is 2. So then we can say our average size for a feature is 2 stories, and the stories are 5 points each. So we've got 10 points for a feature. The reason we use the number of stories rather than the kind of size is because when we start looking at this in more detail and it comes up to the team actually looking at working on them, we're going to have broken that down into stories at that point. So as soon as we start breaking a feature down into stories, then we fall back into these examples where we're actually counting up the actual number of points for the stories we've got. So if this suddenly becomes bigger and we've suddenly got 5 stories, then our averages will update. Okay, so we add this extra feature in our backlog, and we can say it goes up to 43. This is a starting point. And we can do this again, so we look at this top epic and suddenly realise there's some more features, so we can put those in, and we can say they're all 10, so we can now say our backlog's gone up to 73. Now, in reality, it's unlikely that we would add 3 features to an epic which has already been broken down into a feature and some stories. This is probably more likely to be an entire epic. So if we did that and we added in another epic, we want to know how big an epic is. And the process for working out how big an epic is the same process we did for features. We look at the number of epics we've got in the backlog. How many features do each of those have? Work out the average number of features per epic. And then we multiply them by the average feature size. So here we can say our epic is probably about 40 points. So what we've done now is working on our backlog. We haven't really changed any of the estimates we've got in our backlog here, so we've still only got 18 points. But we've started to understand a little bit more about the total scope of work we're going to be delivering. And we started to make an estimate of how big that work is. So we can now see we've got 113 points in our backlog. So we've started with 18 points, and now we're forecasting that we've got to about 113 points. Now, this is still an estimate. It's still not a perfect way of, we're not saying this is definitely going to be 113 points, but we have started to identify a certain amount of risk in our project, in our planning. We've said we know we've got 18 points, but there's probably a whole bunch of extra work we've got that we need to start thinking about, or at least considering when we're talking about forecasting. So the question is, how is this information actually useful? How do you use it to give you some value? So if we look at something like this, so here we're looking at feature progress. So we've got bars which show work that we're doing. Green bits are work that's done. Blue is work we're currently working on. And the silvery bar is work that we've estimated, but we haven't started working on yet. So if you look at feature 2, you can see that this is done. So that's all good. Feature 1, we're probably about just under halfway through doing that. This one, we know we've estimated all the work here, so we've got a pretty good idea of how far through that we are. If we jump up to kind of these features up here, 7 and 8, you see we haven't actually started working on anything here. We've got a whole bunch of points that we've estimated, so there's a certain amount of work here. If you didn't do any of this forecasting in your backlog, you would know that you've got about 8 points for feature 7, and you'd probably know that you've got some other work to do, but you don't really know how much work that is. So by adding this extra kind of dark grey area, which is our forecast amount of work, we start to see actually it's not 8 points, it's actually 13 points. So you get an idea there's probably about half again amount of work left on top of the stuff we've estimated. And that's interesting when you look at kind of feature 8, it's actually jumped up quite a lot here. So in this example, there's a lot of unknown. So this straight away gives you a visual representation of how much unknown do you actually have in your backlog. So you can start to use that to help you have discussions with product owners or with the team generally, just to start to work out what we do about that. It might not be a problem, it might just be something that we're expecting, or it might be something you actually want to, it's highlighting an issue where you haven't planned, broken down enough work in the backlog. This is all fine and dandy, having the feature breakdown, but I think when you roll it back up to the kind of the next level, if you look at Epic level, it starts to give you an interesting picture. So if you look at Epic 1, we're quite far through delivering this. And we've got a bit of extra work here, but when you start looking at all of the forecast work we've actually got as much work as we've already done that is currently sitting in the backlog that isn't broken down or isn't estimated by the team. So we need to start looking at, that gives you an idea of how much total work we're likely to be doing. So it gives you a slightly more accurate indicator of how much work there is. The other way that this is useful, if you use the burn chart that we looked at earlier, you can use something like this. So again, we're looking at green is done. Here the red line is our forecast velocity. And the silver part is the total work that we've got estimated in the backlog. And the dark grey is work that we're forecasting. So see at the start of the project, we've got a whole bunch of work that's forecast and nothing's really been estimated. And as we get closer, we're obviously completing work and more things are being estimated. What's nice adding this extra forecasting logic in is it starts to, when you're predicting out using your velocity line, you can start to look at how it impacts your release date. So here, if we just had the work we've got in the backlog, we'd be able to say, well, we're probably going to be releasing everything, finishing everything in our backlog kind of August-y time. And you would know that wasn't right. You would say, we're currently forecasting for August, but we know there's some stuff that we need to still break down. When we add this extra dark grey part in, you can see it kind of pushes that line right out, so you can now see we're releasing quite a lot later. So it starts to give you a slightly better indicator of when you're actually likely to be releasing. So using evidence-based forecasting allows you to start understanding how much work you've got in your backlog. And you generate this every time you generate the chart, and it starts to, as you start to break your work down into smaller and smaller increments and the team start to estimate, then we start to get more and more granular values coming back, and the averages become more and more correct, accurate indicators of the actual work of the backlog. So by adding this in, you start to get a better understanding of how much work you've got. But if you're trying to forecast the future, you also need to make sure that this red line is a good line. Because obviously this red line is determining when all the work will be completed. So the red line is our velocity for the team. So the question is, how do we start to demonstrate some control around our velocity. It's inherently quite a volatile measure. So how do we start to understand and demonstrate that there's some control around that? So for this, we've been looking at using control charts for measuring velocity. So it's a quick primer on control charts. So control chart is a chart that is used to measure a process and to look at a process to see whether it's in control or out of control. It's used quite a lot in manufacturing to look at how machines work and whether they are delivering widgets in a consistent way. The control chart has a few elements. So you've got your data, you have a center line, which is your average, and then it always has an upper and a lower control limit, and more often than not it splits that into 1, 2 and 3 levels of control limit. So a control limit you can think of a little bit like a standard deviation. The kind of mathematics behind generating it is slightly different, but for the sake of argument today, it's basically like a standard deviation. And the nice thing about using control charts to look at processes like velocity are there's a lot of statistical analysis that you can do on that control chart to start looking for outliers. So the outliers you can look for are broadly split into 4 different categories. So you can look for a shift in the data. So this is where you've been going along with a process that's in control and then something's happened and it's either shifted up or shifted down. So it's a good or a bad thing. And then it's carrying on in control. You can look for a trend. So where your data starts to, so it's going along quite randomly in the middle, and then it starts to have a trend of multiple points going up or multiple points going down. It can start indicating there's a potential problem. You can look for abnormal patterns. Our abnormal patterns category is kind of a catch-all. So it could be that you've got a strange distribution of particularly low or particularly high points, or you could have just one point that's really high. Actually, that's probably a special case outlier. But you can also look at, have you got a particularly high percentage of your data points? Are they above or below a certain threshold? So using these checks on the data can sort of highlight points in your velocity chart over time that could be of interest to you. So they don't control it in their own right, but they're just a helpful hint to help you have the right conversation with your team. So let's have a look at an example. So this is an example of team velocity. Now, just looking at it like this, there's a few things you can probably see. It's quite up and down. There's a few too many zeros. So there's probably something you'd have a conversation with your team about. But what I'm interested in looking at is, I can see it's going up and down, but is this up and down something that we should be concerned about or not? So we can make this look a bit easier to read by adding on some control limits. So the control limits, the solid green line is the average, and then we've got a 1 sigma confidence limit, 2 sigma confidence limit, and an upper confidence limit. And then coming down 1, 2, and then the lower confidence limit is on 0. So because we know something about this process, the velocity process, we know it's impossible to have a negative velocity in any given data point. So we can fix our lower confidence limit to 0. And by doing that asymmetric confidence limit analysis, there's some slightly different checks that get performed on the data set to highlight these outliers. So I think just by adding these confidence limits in, we can start to see, well, this is going up and down quite a lot, but it's not massively outside. A lot of the points are still kind of within our 1 sigma limit. So there might not be anything kind of catastrophic to worry about, but we've still got a few kind of points up here and we've still got these zeros. So let's look at this example when we apply the control limit algorithms to it. So it highlights a few points. So we'll talk about these points. So we've got these red squares. So these are highlighting abnormal patterns. So these are actually highlighting that we've got 2 out of the 3 last points are outside the 2 sigma limit. So this indicates that there could be a trend here that your velocity is too low, lower than you'd expect for a randomly distributed piece of data. Now, these ones, not quite so concerned about. They're right at the start of the project. I think that's quite normal that you'd end up with a low velocity, you kind of ramp up. But it's interesting kind of looking at these ones, right, we suddenly drop down. So this could be a point where we would highlight this and raise it in one of the retrospectives and say, well, this is interesting. We've got this data. Have we got any ideas why this has started to happen? We'll jump over these ones for a second and look at this one. So these yellow squares, these are showing a trend. So in this example, it's showing that there's 7 consecutive points that are above the center line. So this is starting to indicate that maybe we've done something. Have we done something here that has caused our average velocity to jump up? Now, if we had a retrospective and we came up with some examples of things we might want to do that would improve our efficiency, then this is a great indicator that that's clearly working. But if we hadn't done that and nothing had changed, then this is highlighting something looks different, so it might be something you want to drill into in more detail. These diamonds got flagged up, and these are quite an interesting abnormal pattern. So these are showing that we've got 14 points in a row where the points alternate up and down. So it doesn't care whereabouts on the chart they are, but it's just saying this point is higher than this point, and then the next point is higher than the one before it, and then it goes lower, then it goes higher, then it goes lower. And that's a very unlikely to be random event that it's just jumping up and down over time like that. So actually, when you look at that, this is something you could bring back into your team, and it might be here that your team are consistently bringing too much work into a sprint. So you're always rolling a piece of work over, and so then the next sprint is slightly artificially high, and then the next sprint you carry on the same trend. So then you have a little bit too much work, you don't finish it all, so you're a bit low, and then you're a bit high the next time. So the control charts, I think, are a really interesting way of providing some extra assistance to your team when you start looking at how in control is our velocity. And it can raise kind of pointers to start a conversation about the retrospective. It obviously does nothing to control it itself, but it is a way of helping to show that your velocity is something that you're trying to control. And it provides a good kind of story back to any of your stakeholders when I find that velocity is kind of an odd thing to talk to stakeholders about, because it's quite an intangible, kind of quite fluffy sort of thing. Yeah, we use these arbitrary points and we just measure them over time, and then that's what we use to predict how much work we can do. Now, it doesn't, when people are expecting you to be thinking in hours or days, then that's quite a weird concept. So I found that having this extra level of kind of layer of control over the top starts to make it seem like it's a more of a real, believable kind of thing you're using. So we've looked at evidence-based forecasting to try and work out this grey bit. We've talked about control charts to kind of give you some control over this red line. So we've now got a couple of things, a couple of weapons in our arsenal to support using this type of chart to predict when we might finish something. But there's quite a lot of stakeholders I've worked with who just don't really like this type of way of presenting progress. This has a sort of a natural imprecision kind of feeling to it. It's just a graph. It looks like you could just knock this up. So, yeah, it does work much better if you've got a stable team, but I think that's true of all forecasting. The more stable your variables, then the better you're going to be able to forecast. I think if you have an unstable team, I'm not sure that's quite the right term, but then you'd expect your velocity to be much more unstable as people leave and come back. So that will be highlighted in kind of these sort of charts. You'd expect to see more outliers. This is a mixture of real data and then modified data in order to get some of the kind of things to tie up. So in the majority of the real data part of that wasn't particularly because the team was changing. The team was static. It was just there was work that we were unclear about how we were doing. So technical issues with doing it. No problem. So there are stakeholders who find this whole burn chart approach to reporting progress a bit imprecise, or whether it's an accurate predictor or not doesn't really matter. It's just an impression you have of something that somebody could just draw up on a whiteboard, and they are looking for something a bit more numerical. So to kind of finish up, I'm going to talk a bit about an alternative way of reporting on progress that starts to try to put some numbers on where we are and whether we're on track or not. So to do that, we're going to talk about Agile Earned Value Analysis. So earned value analysis is something that's much more common in waterfall projects or construction projects. It's a way of comparing performance against some baseline measure in an objective way, and aims to give you some key metrics. The key metrics are schedule performance index and cost performance index. So these are numbers that are anything below 1 means you're behind where you want to be for schedule or under budget. Anything that's plus CPI, a positive number is over budget, and negative number is under budget. So it tries to give you some numbers that you can then use to compare projects against each other without knowing anything about the detail of the project. So let's look at an example of what it looks like. So it doesn't look massively different. So we've got a blue line. This is showing our kind of ideal progress over time. The green line is showing us basically our actual progress. This is our earned value. And the yellow line here is showing the actual costs, so how much have we actually spent. Up at this top corner, we've got the CPI and SPI numbers for these last data points. So you can see that the CPI is greater than 1. It's showing that we're tracking under budget at the moment. And our SPI is just under 1. Means we're behind where we wanted to be, but not massively far behind. So you can look at these numbers and you can take those for different projects, and you can use that as a comparative measure between the projects to see whether they're on track or not. So let's look at how this actually works in practice. So there's a bit of work to do at the start. So in order to calculate your earned value, you need to have a baseline of what you think the project looks like at the start. So there's a bit of upfront work here. So you need to estimate how much work you think is in this project in points. And you can use some of the evidence-based forecasting if you've got historical data for your team, or you can sit in a room with some of the team and just do your best guess at how much work there is. But you need a starting point. You also need to estimate how many sprints you think you're going to take, so how long is the project going to be. And then when you know how many sprints you've got, you know how big your team's likely to be, so you can work out how much you're going to spend. So you end up with total cost, number of sprints, and total amount of work. So you do that right at the start, and then every sprint you capture the current sprint you finished, the current number of points you finished, the current backlog size, and the total spend. And then once you've got these two bits of data, you can calculate your earned value metrics. So this is obviously an example for demonstration. So this is a perfect example. We're here halfway through our 30 sprints. We've completed 1,000 points out of a total of 2,000, and we've spent $500,000 out of a budget of $1 million. So we're bang on target. And our CPI and our SPI numbers are both 1, full green. It's predicting we've got another $500,000 to spend, and everything is looking lovely. So let's look at a few examples of how this works when you've got different numbers. So say we got to the same point in the project, and we'd only, instead of completing 1,000 points, we've only completed 500. So we spent the same amount of money, but we have delivered much less. So in this example, both of our numbers drop down to 0.5. So this is saying we're pretty far behind where we wanted to be schedule-wise. And because we spent half the money, but we've only delivered a quarter of the work, we're also quite far behind cost-wise as well. So we're pretty over budget. Just an example to show you kind of the other way around. If you had completed 500 points, but you'd only spent $250,000, then the numbers would switch a bit. So we're still pretty far behind schedule-wise, but we've only spent a quarter of the money. So actually we spent the right amount of budget for the amount of work we've delivered. So budget-wise, we're on track. So we got a 1 for our CPI. If we had overspent, so in this example we completed 1,000 points, so that's half the work done. So our CPI, our SPI is 1, but we spent $750,000. We're now massively over budget, so we're on track for delivery, but we're spending too much money. So this is showing that we've got a CPI of 0.5, and it's also predicting here we've got another $750,000 to spend to complete the work that's remaining, and that gives us our budget's going to jump up to 1.5 million. So in all these examples so far, we haven't changed how much work we're expecting to deliver. So this is just really showing progress against some baseline. If we look at an example here, we're back to where we were. We're halfway through the project. We've delivered 1,000 points out of the 2,000 we started off thinking we had, and we spent $500,000. But at this point, we've started to look at our backlog and realise that it's a bit bigger than we thought. So in this example, our numbers here have dropped down by a less easy number, so they've gone down a little bit. So this is now showing you that in order to finish everything that's in the backlog, we're now too far behind where we want to be. So we might have been totally on track for what we thought we were, but the actual total work has changed, so we now need to be further ahead. So this is giving us an indicator that there's something that we might want to investigate with the team. So I appreciate that's a bit of a lightning walk through earned value analysis. If it's something you're interested in, there's a really good paper by some guys at Solutions IQ that goes into a lot more detail about the mathematics behind how you calculate those numbers, and have some analysis on there about how good a predictor it is of progress in your project. So if it's something you're interested in, I think this is a really good paper to look at. Okay, let's recap the last 30 minutes or so. So I talked about evidence-based forecasting. So this is a way of using historical data from your team over time to start quantifying how much unestimated work you've got in your project. It's an interesting way of being able to start to highlight some of the risks that you might have just of unknown work. in your backlog, and it helps to make your burn charts a more accurate representation of how much work you've really got. We talked about velocity control charts as an additional layer that you can put on top of your regular velocity reporting, and you can use that to start to look for outliers and to start helping you to drive the right conversations in your retrospectives to look for potential problems or potential good things that you might want to do more of or do less of. And it's something that I found helps the stakeholder engagement when you're talking about velocity. It starts to show that you're taking that measure as something that's quite a serious measure that you're using as a core way of forecasting your future delivery. And then I talked about earned value analysis as an alternative approach for reporting progress. So it doesn't in itself really change any of the kind of planning and the reporting, but it gives you some slightly different numbers and slightly different mechanism for showing that progress. And it might be something that's useful in your organisation. I've had quite good success using this type of approach when we've had projects where some of the teams were working in a more agile way and some teams were working in a slightly more waterfall way. And if you've got a set of stakeholders who have got quite high governance, then this is something they quite like. It tries to put financial numbers against some of the reporting. It's not a great fit for every project, but it's an alternative that might be useful to you. That's everything I know about forecasting. Thank you very much for your time. We've got a bit of time for some questions, I think. If you like.
So, if you're having safe forecasting,
Mm-hmm.
what would you do if you discover that you estimate value of somebody and actually, all of your, when you're actually speaking with stuff, you're actually long and so on. So how do you then look at that? Do you need to go into the estimation?
So I would probably not change that estimate because I think over time your team is going to underpoint and overpoint a similar amount of work. So I think it's a bit of a you win with some, you lose with others. So when you're looking across multiple sprints worth of work, then I think those differences will average out over time. So because you're using average data in order to fill in any gaps you haven't got, then that variability should not be something that is significantly affecting any of the forecasting numbers. I don't know. I'm sure there is. It's ultimately just adding up averages. So yeah, I'm sure there is a way of doing that, but I don't have the mathematical nous to do it live on stage here. Yes.
How accurate is that forecasting? Whenever I get asked to do that, it's just
Mm-hmm.
they want to say, presenting that, I'm always saying, this is where I'm at.
Mm-hmm.
But if those sort of calculations, is it more likely to be better or worse?
So I think there's two bits to that. So I think when you're doing that type of forecasting, you're usually doing it to predict quite far into the future. So it's usually 6, 12, 18 months into the future. So your window of accuracy is usually quite a big window. So you're usually looking for, are we looking at quarter 1 or quarter 2 for delivery? So I think for that type of forecasting, then I think this is probably accurate enough. What I've been doing with it is calculating every week, and then capturing the forecast end date each week and tracking that over time, so I can start to see how volatile is that forecasting, so I can see if we're trending up or trending down. So actually kind of more looking to see, so we've got a project that we would like to finish at the end of next year. Now, are the data we've got at the moment forecasting that we're in the right ballpark for that within a quarter? And are they changing quite a lot over time? Now, it's really hard to work out how accurate it really is, because you'd like to be able to say, well, this is what I forecast right on day one, and this is what it actually took at the end of 2 years. But the reality is that over 2 years, what you've actually delivered is probably going to be quite different to what you thought you were going to deliver at the start, which is why you want to do that kind of mathematical forecasting, to give you the flexibility of changing your backlog as you go along. So I think the answer is I don't know how accurate it is, but it's been a useful tool for me to be able to look for trends in how is the end date that we're forecasting slipping or coming back in. That's all organisations, isn't it?
What we're doing is a load of data in that way, and how do you translate that into information?
So I think that trending of this is how that forecast end date is changing over time is a good way of showing how secure you are in that date. But ultimately, there's a lot of conversation you have to have around what you're asking for is me to predict the future. You're asking for what's going to happen in a year's time. That's actually a really hard problem to solve. So I can give you this estimate, and that I have some unknown around that. So I'm happy to say plus or minus a few months, and that few months will depend on information you have in your head about how well defined your project is. I think you ultimately have to have that conversation with the stakeholders to say, look, I can give you this, but this is the level of uncertainty that I have. Yes. So I'm using all the history. I think what you would probably do is you'd want to see if there was a really significant difference in your how you're estimating from kind of year 1 to year 2, or half year 1, half year 2. I think that's something you'd probably want to do anyway, just to make sure you're not, as a team, having inflation in how you're treating points. So if you've got a fairly consistent way of pointing, then I think there's no problem with going back right to the start to all the data you've got. I think so. But ultimately, the more data you have, the better your averages are going to be, because any variability you've got will kind of disappear out. Mm-hmm. Mm-hmm. So that becomes a challenge of what you're then trying to do is estimate something you really know nothing about. So this is basically saying I've got 50 epics, and over that 50, I'd expect some to be bigger, some to be smaller. So I'll use the average, and that should kind of account for some of that unknown. And then as you start understanding more about that epic, you'll break it into features, and then you'll start to use the actual number of features you've got to get your forecast a bit more accurate. And then as you start understanding that, you'll kind of create more stories. And ultimately what you do as you're going down that process of elucidating more detail in your backlog, you might well decide that actually these two features that were with Epic 1, actually this is now another Epic, so let's split those out into another Epic. So you want to be able to have your flexibility in your backlog. And what this is trying to do is give you an option of keeping that flexibility, but being able to also kind of give an estimate of how big those things are as you change it. But I think that's fine. You still come to that later. You would just say, I've got an Epic and it's going to do something with direct debit, and it's probably going to be a similar size to the average size we've got of all the Epics in our backlog. And then as you start getting to the detail, you go, oh, actually, that's a bit more difficult. And that will move your forecast slightly, but, or it might move your forecast. But then you might also, at that point, be a further down your development cycle that you can find a better way of implementing that is easier. So you kind of win with some, you lose with some others. Yes. I have thought about it, but I haven't done anything with it. I think Monte Carlo would be a really good way of kind of getting a different take on the. Yeah, I think that's a good way of looking at it. It becomes a bit more complicated to set up and calculate. So this is a kind of a quick and dirty option, I guess. But Monte Carlo would be a nice way of giving you a bit better kind of thing about level of probability around it. You're right. I think there's a question. Mm-hmm. Yeah, you just give a date. Yep. I think that's a good approach. The reason I haven't gone down that route at the moment is I think when you're going that far out, you already know there's quite a lot of change, and you've actually usually got quite a lot of flexibility in the detail of what you deliver. So you can have an Epic that says, I'm going to deliver this capability to the business, but actually that capability could change. The amount of effort it takes to do that could change quite a lot over the time. And I think if you start to look like you're forecasting too late for the stakeholders, then you'll naturally become a little bit more strict about how many of the nice-to-have stories you actually pull in. So I think you kind of naturally try to limit your backlog a bit as you get closer to the end date. But there's, the more kind of information you can have about how clear you are about that forecasting is good option. Yes, at the back. So there's nothing in there about quality. I think that then just falls back into your standard way of working, where you have your definition done and that's your measure of quality. I don't think that's any different. All right. Yeah, that's great. Thank you very much, everyone.